Welcome to today's tip. Now we're going to look at a very simple financial model today and look at some of the functionality that's show you on this website and put it together to create, as I say, a very simple financial model. Now Albert Einstein once described the concept of compounding interest as the eighth wonder of the world, and we're going to see why today. Now obviously, for those of you that don't know, compounding interest is interest on interest. So we're just going to show how using the concept of compounding versus just putting money away and earning no interest, how the actual value can exponentially multiply over time. And I mean, that, I suppose, just from a finance point of view, that's the thesis for why you should invest and earn a compounded return on any money that you save or earn. So if you just look, jumping straight into the simple financial model, you see we've just got an illustration of compounding. We've got some assumptions here. You can see the assumptions denoted by the light blue background and blue text or font color, with some labels next to some of the assumptions to give a bit more information. Now that's just using some styles. We've chatted about styles before on this website, so I've set up some input styles for numbers and percents, etc. And dates, so just worth doing in your financial models in general. So here we've got a monthly investment amount, an annual increase in the investment. So for example, it's quite reasonable to assume as you work in your job you get an annual increase, so you might want to increase your investment when you get a salary increase. So for example, increase the amount you save or invest each year by 10%. And you'll see how that magnifies your returns as well. Then we've got an assumption for the actual return. So I've got 13.5% here, which is not an unreasonable assumption going forward for what the South African stock market may return over the long term. I mean, obviously there's different views on that. I've got the number of months in the year being 12, and then I actually calculate a monthly return. Over here I've got an annual escalation flag. So you'll see, I'll just scroll across here. And you'll see in the cell there, on the anniversary of the start date of the model, a 1 appears, and you'll see how we use that going forward. Then I've got a start date, so I've just put it here at the first period for ease of use, as it is a simple financial model, so we choose the end of this month. We've got an opening balance, which we're going to assume to be 0. Then we've got a monthly saving amount coming in, a balance after the savings, so there's an inherent assumption that the savings come in at the beginning of the month. We calculate interest on top of that saving, and then get a closing balance. That closing balance with the interest is then sent up to the opening balance, so you end up calculating interest on interest, which is compounding. Just got some running totals here, which is accumulated saving amount, so without any interest, and then the cumulative return, so all the interest. So I just split it into two separate parts. There's a section down here called data table, but we'll get to that in a sec. Let's just have a look at the financial model. Okay, so to start with, we're going to say we're going to invest 5,000 Rand a month. We're not going to have any increases per year. We're going to have the return I talked about. The annual escalation flag will always be 0 in year 1, because obviously you don't want any escalations in year 1, in month 1. But we'll look at the formula for this. So basically what I've said is if month in J16, which is the first period, is equal to the month in K16, which is the period we're in, then do what's the logical value, which will be true or false, and using the end function we'll get 1 or 0. So you'll see before, when we had where we've got the 1 in the September period, here the start date month is September and the month we're in is actually September, so that's true, and then we convert it to a number which is 1. The start date in the first period, as I said, is a hard-coded assumption, but for the next periods we use the EO month function, and we look at the prior period and we just go 1 month forward, and so on. Here we have used a hard-coded 1 for the fact that this is going to be always a monthly model. Best practice, I suppose, is to actually have an assumption that this is a monthly model and refer that month's term or argument to that assumption. But with a simple financial model, it's not really needed. We've got an opening balance of 0. You can see the 5,000 comes in every month. get a balance after monthly saving in the first period. It's 5,000. We calculate the interest, which is the 13%. We use absolute cell referencing to lock it into the 1.13%. We use the absolute cell referencing to lock that value in, so in every period it refers to that cell, but it refers to the individual balance in each period. So we get 56 Rand in the first period. Our closing balance is 5056. This then moves up into our second period. We calculate interest on that 5056 plus our investment of 5,000 gives us 10056. The interest is now 513. We get 10169, and so on. And that pattern carries on over the entire period. Now I've run this model out to the, I'll just scroll across here so you can see, to the 31st of August 30. Just if we count all those cells, that's 240 months, which is 20 years. So we're looking at a long-term picture here, which I suppose if you're looking to make investments, you should have a long-term view. Just to look at some of the formula, I'm just going to ungroup those cells here. You'll see I've just also got some total rows here just to show me my total monthly saving and the compounded return. Interesting to note here is you can see how much higher the compounded return is than the actual monthly saving. Okay, so let's jump into the formula. Here you'll see I just refer to the prior period's closing balance for the opening balance, which is pretty self-explanatory. In this first period for the monthly saving, I've used an if function and an is blank. In all my models I always keep column R blank, and that's to be able to do a different calculation in the first period if I desire. So I've said if the R19 is blank, then refer to the assumption for the investment, so the 5,000. If it's not blank, which in this period isn't blank, so we'll move across there. So there's a value there, so it's going to look at the false argument. If we look at the prior period's investment, and we take 1 plus the prior investment, and we now bring in this annual increase in investment. So we've got the J9 here, so whatever percent we put in here, so it's the percentage increase times by the escalation flag. So every period every annual anniversary it'll escalate your investment by a desired percentage. Okay. The compounded return is quite simple. Just take the balance times the interest, and then we sum up a few times to get the balance after monthly saving and the closing balance. These totals down here are just sum functions. You'll see I've absolute referenced the column, so as we go across we start picking up all the cells. Same thing here. I'll take the closing balance less the initial investment to obviously find the cumulative return. So it's pretty simple so far, but let's just play with some of the values. So let's say we increase our investment by 10% every year, and just go through to our model, go across. You'll see now on the 30th of September 11 our investment is 5,500, so there's the escalation. Just going to take that out quickly and go down to our data table. So I've done a two-factor data table here, which all you do is you go into data what if data table, and this dialog box will appear, and you put in the row and column input cells. You can use F1 and help to also get a bit more information. Now, just before we get onto the actual table I've created, you see I've got the start and end date here. So the start date is just a reference to the start date assumption. The end date is the maximum date in this range here. So I say choose date. So we've got the last date here, the 31st of August 30. It's potential to put an incorrect date in here, so I've used some data validation, so I'm just going to click on that. You'll see put an error alert in here first of all, so it's please enter a date between the start and end dates. And the way I make a user do that is I go into the validation criteria and I say allow only a date input between J29, which is the start date, and J30, which is the end date. So you see, if I put in like 2045 here, it'll say please enter a date between the start and end date, and I'll just click cancel, and we go back to our original value. Now you'll see I have also, because of the being able to select the dates, done an index match. Yeah, so in the index match I look through all the closing balances and I match the calculated date, which is just an EO month, to make sure we go to the end of the date, so it can match in the period headers, which are all at the end of the month, and I find the closing balance as at that date. So at the 31st of October 30, with all these inputs, the value is 6,138,000 Rand roughly. Now if I just change it, so let's just go to 2020 here, you'll see that updates. So now it looks at 121. So I'm just going to prove that. So we go across to the 30th of 20 August, and you'll see that balance is equal to that balance there. So that's pretty neat as well. Then I've just hard-coded some assumptions in the data table. Let's go across a bit so you can see them. And start at 2,500 and a 6% return, and escalated up to 18%, and we go across to 17,500 just off the screen here. And now this is all the different values that your closing balances that will be generated based on different contribution amounts and different investment returns. So I'm just going to key in 13.5% here to show you how this table can be dynamic. So I key that in there, and we get 1271236 in the 5,000 and 13.5%, which is again equal to our base case. We see if we move across, increase our contribution, the value goes up, decrease goes down. We expect that. Obviously, the higher investment return or generates a higher closing balance. I'm just going to change this back to 30 as well, what we originally had, and talk about a chart that we've drawn here. Now you'll see, I'm just going to move this chart over here so you can see it a bit better. We've got a cumulative return and a monthly saving. So that monthly saving, the blue amount, is just if we earn no interest and just saved all the money, what will we end up with? The green amount is the actual investment return. Now you can see over time, as time increases up till 2030, the two lines actually start diverging from each other. So you look, this area over here, this green area, grows exponentially over time, and that was what Einstein was talking about when he said it's the eighth wonder of the world. So you can actually put your money to good work by using the concept of compounding. What we're going to do here is, let's just play with some numbers. Put the annual increase to 10% a year. Say we're going to earn 15%, and you'll see now over the 20 years how much higher the chart goes. So now that'll, with the new assumptions, we'll earn 14 million. Well, our capital balance will be 14 million at the end of that period. Let's just put some other numbers in here. So let's just say we up this to 10,000. Now you see we head up towards 30 million. But you can see that the slope of the line gets steeper and steeper as you increase your investment amount. So yeah, that's just a very simple financial model, just something I was playing around with one day.